All right, good morning, everybody. Welcome to today's class, Organic and Inorganic Chemistry 2. And this morning we'll be looking at communicating chemistry and material chemistry. I'll be using the first maybe 7 to 10 minutes to talk about communicating chemistry. And then I'll now talk about the emphasis will be on material chemistry. So let's proceed. So communicating chemistry. Communicating chemistry basically covers the practice of disseminating chemical informations, whether in form of news, discussion, data, or structures, which has been improved and complicated by advances in information technology. So what I'm trying to say is that there's need for every information that comes from as far as chemistry is concerned to be able to communicate it to the world to see. So it also includes discussions of best practices for engagement with the public, whose misunderstanding of the topic can be detrimental to the progress of the discipline. Now, what this means actually is people don't really understand science. People don't know people don't understand what is happening in the world of science, especially in chemistry. So there's a lot of speculations here and there about science, especially in chemistry aspect. So there's need for us to be able to, as scientists or as chemists, to be able to do this, to communicate so there won't be misunderstanding. Like the current coronavirus, the COVID-19 that's been ravaging the world. There are still parts of Nigeria that don't even believe that there's COVID-19. Kano now, it's the upsurge in coronavirus in Kano. It's quite worrisome. And even as of yesterday, there was a video that was released in the social media of people doing a particular local government in Kano doing a coronavirus tournament in form of football, and people were gathered. There was no social distancing. There was no observation of every NCDC guidelines as far as how to prevent this coronavirus concern. So this becomes necessary to actually communicate chemistry science to the general public so that they can understand what they are into. So that's the emphasis for this particular. So why do we need to communicate chemistry? Number one, like for example, for the safety of food and medicine, that's number one, very important. What are the guidelines? How do we stay safe? Okay, as far as consumption of food and medicine is concerned, the consequences of ocean acidification, ensuring clean water, mechanism and effect of climate change. These are the things. These are the reasons why we need to communicate to inform people, okay, globally on a timely basis, these informations. And then it also brings about a sense of responsibility, okay, because as a scientist, if I have something, if I have an information which I know will impact the society, whether be negative or positive, it is necessary for me to be able to, it will be a joy for me to share what I know to others, which can also help to keep our next generation, okay? And then communicating chemistry can also encourage people who want to take a career, in chemistry to actually pursue it, because people can get interest from what they see, what they hear when these things are being communicated to the general public. So it can encourage some people to actually pick it up as a career. So these are some of the reasons why we need to communicate chemistry. And then what motivates chemists? Increase public appreciation and excitement for chemistry as a source of knowledge about the world. So people are beginning to understand now. For example, the COVID-19 we're talking about now. There's excitement that, oh wow, science have been able to tell us what's going on, what to do, how to prevent it, the safety measures and the rest of them. So there's an excitement that it creates, there's this appreciation that it creates among the public that, okay, we are being carried along as far as science and the rest of things is concerned. And then it also motivates chemists to understand the consumers the more, what they need, and how to solve their problems. Because by the time they pass an information, you must definitely get a reaction and counter reaction. So from all those reactions and everything they're going to get from the general public, that will help them to form to get a better idea of what to do in the nearest future. So that's also one of the major things that motivate chemists. It empowers informed citizen participation in democratic processes, especially in decision makings, things that affect us and the rest of them. And then it also encourages workforce development in the chemical sciences. So these are some of the things that motivate chemists as far as that is concerned. Okay, so let's move ahead. What do chemists gain? There's an excerpt from a researcher from Inverness Research Associates in 2009. He said something. He said, every time I've seen a scientist engage with the public, they get a better understanding of their own research and its contact to society and how their research actually impacts people and the environment. So in communicating chemistry, there's a lot that chemists gain. Just like I've told you initially, it helps the researcher understand the society more, what they need, and how it can make the environment a better place. Then the benefit to their work, they get more ideas, okay, of what is going on, and the rest of them. So that's basically is a joy for every chemist when they actually get those such kind of responses. And then the framework for effective chemistry communication, set communication goals. That's number one. Okay, set communication goals and outcomes appropriate to the target participant. So what do you want to communicate? Okay, what are the goals of what you want to communicate? So you have to first of all set it, and then make sure that it gets to the target participant, those who are concerned. It gets to them. It is not every information that you give everybody. Okay, so there must be a target participant that that particular thing is meant for. Okay, so set communication goals and then make sure it gets to the target participant. Then identify and familiarize yourself with your resources. Okay, resources for communicating, communication resources. That's what we're talking about. Okay, familiarize yourself with them, like what we're doing right now. We have to really familiarize, even if we are still learning some things, familiarize on how to use webinar to communicate lectures to our students. So chemists must be able to familiarize themselves with the resources available to them in communicating this science of this information. Then design the communication activity and how it will be evaluated. The president, since this COVID-19 started, the president set up a PTF, Presidential Task Force. And one of the things they set, one of the communication activity they set is they brief Nigerians on a daily basis of of what is happening as far as coronavirus is concerned. So every between 5 p.m. and 6 p.m. they come to tell Nigerians this is what we're doing, this is what is happening. And then between 11 p.m. and 11:30 p.m., if there's a case of new coronavirus, they give us the statistics and everything across the states and federation. So that's what they've set for themselves. That's a communication activity that on a daily basis we must inform Nigerians this is what's happening, these are the efforts we are doing, the palliatives and the rest of them. So in designing your framework for effective chemistry communication, it's necessary to do that. Okay, design the communication activity, how will it be evaluated over time? And then once these first three items are done, you can now begin the communication. So number 1, 2, and 3 is a proactive measure. It's something you do before a pre-communication stage. And then number 4 and number 5, which is communicate, is actually the communication itself. Okay, then at the end of the day, you assess, reflect, and then follow up the information that you've already passed to them. So that's the framework for effective chemistry communication. So quickly, let's go to introduction to material chemistry. Introduction to material chemistry. Let me see if I can increase my slide so that it will be clear enough, or people can see it more clearly. So the objective is to understand the various classes of chemical industry and the specific raw materials that they use. That's number 1 objective. Then the second one is to understand the procedure for the production of some industrial products. So these are the 2 objectives we achieve as far as this this thing is concerned, this lecture is concerned. Okay, so let's forge ahead. Raw materials for chemical industries. Man basically depends on the basic industrial products, okay, such as drugs, dyes, glass, paint, plastic goods, cement, fertilizers, ions. These are different things that man depend on for their daily needs and the rest of them. And all these things I just mentioned, the dye, the glass, the drugs, the paints, the plastics, the goods, all of them comes from, you know, organic and inorganic raw materials. So these raw materials that is used to produce all this thing I just said falls into two categories. Okay, we have the inorganic materials and then we have the organic material. Okay, so we'll be looking at them one after the other. Okay, for the inorganic materials, these are raw materials that are of inorganic origin. Okay, they are of inorganic origin. Examples include sodium chloride. Just as you can see from my slide, sodium chloride is an inorganic raw material. And what they produce, as you can see there, from sodium chloride, you can get the products include sodium and chlorine, sodium metal, then sodium hydroxide. You can get these products from sodium chloride. And then the calcium trioxocarbonate 4, the products, the quicklime, which is the calcium oxide. And then we have the slake lime, which is the calcium hydroxide. Then another inorganic raw material that industries use is the magnetite. You get iron from there. And then the coal, you get coal gas, coal tar, and coke. So these are some of the things you get from the inorganic raw materials. Okay, then for the organic raw materials, industrial raw materials that are of organic origin are these ones, like the wood, the natural gas, the animal cells, the vegetable oil, and the crude oil. Okay, so I'm going to list them one after the other. That's the natural sources and the uses of these raw materials. Okay, so for the organic raw materials, you have the wood, the natural gas, the animal cells, vegetable oil, and then the crude oil. These are the organic raw materials. So the natural sources and the uses of industrial raw materials. There are basically 4 natural sources of these raw materials. One of the sources is the earth, we have the air, water, and then agricultural products. These are some of the sources that you get these industrial raw materials. Okay, so for the earth, I'm going to combine the earth and the water because they are both in the same biosphere. Okay, so I'm going to combine them together to explain their uses, okay, their sources, and of course the uses. Now, of course, we know that the earth is the natural source for rock salt and seawater, even sodium bromide, magnesium, and sand. These are some of the raw materials that you get from the earth. Okay, then other raw materials also include limestone. You get that from the earth, natural gas, the ores, the petroleum, and of course the sulfur. So these are some of the things you get from the earth and of course from the water. Now, what are the uses? For example, please write, because I don't have that particular slide here. So I'm going to list their uses one after the other. Now, these are the things I've already explained that you find in the earth and of course in the water. The seawater, the coal, the coke, the coal tar. Number 3 is coke, the coal gas, limestone, mineral oils, natural gas, crude oil, and sulfur. So I'm going to be explaining them one after the other, their uses as far as industrial raw material is concerned. So for the seawater, please write and follow me. Once you do electrolysis, we'll be looking at that electrolysis as a topic in this particular course, so they understand it. It's what we call electrolysis of brine. Okay, once you do an electrolysis of brine, which is salt water, you get some products. It produces sodium hydroxide. So from salt water after the electrolysis, which is the brine, you get sodium hydroxide from it. You get sodium, which this sodium hydroxide actually is actually used in making of soap, textile, that's cloth, and of course for paper industry. So you see, from the electrolysis of seawater, which is the brine, you get sodium hydroxide. Now, in industries, this sodium hydroxide is used to make soap. It is used to make textiles and also used to make paper for the various industries. So that's that. Then this same brine, this salt water, when it's treated with carbon 4 oxide, please write it down. I don't have a marker here. Now, when this, let me take it again. I said, first of all, through the electrolysis of brine, which is the salt water, you get sodium hydroxide as one of the products from that electrolysis. And I said that the sodium hydroxide is used in manufacture, in making of soap, textiles, and paper. Okay, that's one. Then number two, when this salt water now is treated with carbon 4 oxide, I hope you're writing. When this brine is treated with carbon 4 oxide, which is the carbon dioxide that we know, it produces sodium trioxocarbonate 4. So a reaction between sodium chloride, which is NaCl, plus, so you can write the chemical, I'm trying to give you the chemical, the NaCl now, sodium chloride plus CO2, which is carbon 4 oxide, produces sodium trioxocarbonate 4, which is actually used in making glass. Did you get that? So that's that. So a reaction between carbon 4 oxide and this sodium chloride is used to produce or in making glass, these glasses that you see. That's number two, use of seawater. Number three is that sodium trioxocarbonate 4 that was produced as a result of the reaction between the sodium chloride and the carbon 4 oxide, which I just explained that is used to make glass. Now that sodium trioxocarbonate 4 can also be converted into sodium hydrogen trioxocarbonate 4, which is used in the manufacture of baking powder. I take it again. The sodium trioxocarbonate 4, which was produced as a result of the reaction between the brine water, which is the sodium chloride, and carbon 4 oxide that produced the sodium trioxocarbonate 4, can also be converted into sodium hydrogen trioxocarbonate 4. It can be converted, the sodium trioxocarbonate 4 can be converted into sodium hydrogen trioxocarbonate 4, which is used in the manufacture of baking powder. So these are the three major uses of seawater for industries. So the seawater serves as a raw material for these industries I just talked about. So from seawater, you can get a material, a raw material that is used for making soap, like I said, which is the first one. The reaction of carbon 4 oxide with sodium chloride gives you the sodium trioxocarbonate 4 that is used to make glasses. And then the sodium trioxocarbonate 4 can be converted to give us sodium hydrogen trioxocarbonate 4, which is used to manufacture baking powder. So those are the uses of seawater as a raw material for those industries. Then number two is coal. What are the uses of coal? Coal is a major source of fuel, just as we know, for cooking and for firing furnace. Okay, even some steam engines, like all these boats, all these ocean liners and the rest of them, they make use of coal. Okay, because the engine is actually, so they convert it to steam that is used to power, the distance. So that's one of the major uses of coal. So these industries use coal to do this. So it serves as a source of fuel for cooking. It serves for firing furnaces and also for steam engine. Okay, so that's number one use of coal: for cooking, for firing furnaces, and for steam engines. Please write what I'm saying so that You can go through your notes later, okay, and get it, understand it well. All right. The number two use of coal is that when this coal is subjected to destructive distillation, I take it again. When the coal is subjected to destructive distillation, valuable products such as coal gas, coke, and coal tar are obtained. When the coal is subjected to destructive distillation, I said certain products comes out from that process, and these products are coal gas, the coke, and the coal tar. Of course, you know coal tar for construction of road, coal gas for cooking, and of course the coke too. All right. So that's also another use of coal. I hope I'm not too fast, and I hope you're following me. Now the coke, which is number three. Now I'm done with coal. I'm going to number three, which is the coke. C-O-K-E, not C-O-E actually. It's a typo error. C-O-K-E, which is coke. Number three, the coke is used in the production of water gas and producer gas. So from coke, you get water gas and producer gas. So you can take your time to browse about water gas and producer gas. Okay. Now, when this coke combines with chalk, chalk is calcium carbonate, CaCO3. When the coke combines with this CaCO3 with chalk, it produces carbide. Carbide is spelled C-A-R-B-I-D-E. Now, this carbide, when it reacts with water, it produces ethane. It produces ethane, which in turn produces the polythene, like these polythene bags that we have. I take it again so that you don't miss it out. I said for coke, which is number three, I said the coke is used for production of water gas and producer gas. That's number one. Now, when this coke combines with CaCO3, when the coke combines with CaCO3, it produces calcium carbide. It produces calcium carbide, which reacts with water to produce ethane. So when you react water with calcium carbide, it produces ethane, and the ethane is what is used to produce the polythene. So you see the industrial use of coke. So that's that for that. The next one is coal tar. That's number four, coal tar. What are the uses of coal tar? Okay. From coal tar, you can get benzene. You can get methyl benzene. You can get naphthalene. You can get phenol. I take it again. I said from coal tar, you can obtain benzene, methyl benzene, naphthalene, and phenol. These are some of the things you get from coal tar. So you see the industrial use of coal tar. Now, these things I've just mentioned to you now, the benzene, the methyl benzene, the naphthalene, and the phenol, they are all used in the production of plastic goods. Okay? They're used to in the production of plastic goods. And which other one now is flying out from my head? Dyes. You can also use to produce dyes, even explosives. Explosives. So you can also use that from coal tar. You can use it to produce plastic goods, dyes, explosives. And like I told you earlier, coal tar is also used for road construction. I hope you got that. So benzene, methyl benzene, naphthalene, phenol are all obtained from coal tar, which is used in the production of plastic goods, dyes, explosives, and of course, used for road construction. So quickly, we'll go to the fifth one, which is the coal gas. Make sure you are writing so that you'll be able to go through these things at the end of the lectures. So the coal gas. The coal gas is actually, I have about 9 minutes to go, so I just hope I'll be able to finish this particular slide so that we'll meet the next time. We'll continue from there. Now, the coal gas, which is a mixture of hydrogen, methane, ethane, and gaseous impurities, are used as industrial fuel. So coal gas basically is used for industrial fuel because it has a mixture of hydrogen, methane, ethane, and gaseous impurities. All right, so coal gas is used for industrial fuel. Quickly, limestone. We all know limestone. Now, this limestone, when mixed with clay at a very high temperature, produces cement. So from limestone, you get cement. Okay, but it has to the limestone has to be combined with clay at a very high temperature to get us the cement. And of course, we know what cement is used for. Now, when the limestone is heated at a high temperature, it is converted to quicklime, CaO, calcium oxide. When limestone is heated at a high temperature, it is converted to quicklime, which reacts with water to produce calcium hydroxide. I take it again. First of all, I said when this limestone combines with clay at a high temperature, a very high temperature, we get cement. We know what we use cement for. Now, this limestone too, once it's heated at a very high temperature, it can be converted to quicklime, which is the calcium oxide. And when you react it with water, it produces calcium hydroxide, which is the slake lime. Okay? Now, this slake lime, when you mix it with chlorine, you get your bleaching powder. So you see why it's also a raw material. So from the limestone heated at a high temperature converts to quicklime. And when the quicklime reacts with water, it produces the slake lime, which is the calcium hydroxide. And the slake lime, once you mix it with chlorine, you get your bleaching powder. Limestone heated at a very high temperature gets converted to quicklime, which is the CaO. When the CaO, quicklime, reacts with water, it produces calcium hydroxide, which is the slake lime, CaOH. And when the slake lime further combines or mixes with chlorine, you get your bleaching powder. So that's that for the limestone. Then the mineral ore, these are metals extracted from ore. Okay, like we have the basorites, the cryolites, and the aluminum silicates. And these are all sources of aluminum. So from this, you can get your aluminum. Okay, aluminum is used to produce roofing sheets, as we know. It is used to produce alloy and also kitchen utensils. Okay, so other products gotten from ore also include iron. You can get iron from there, which is used for the production of ornamental gates. So from ore, you can get iron. It's used to produce ornamental gates, boilers, and then making of steel. Yes, to make steel. Okay, now this steel is actually used for construction of bridges. So from iron, from ore, you get steel, and this steel is used for construction of bridges. Okay, it also used for construction of roads, for buildings, even manufacturing cars, motor vehicles. So most of our cars are made with steel. So those are the industrial uses of ore. So from ore, you get aluminium, which is used for roofing sheets. From ore, you get iron, which is used to make ornamental gates. And then from ore, you also get steel, which is used for construction purposes, whether it's bridges, road, buildings. It's also used to manufacture the body of a car, motor vehicles. Then copper is also gotten from ore, like the copper pyrites. Okay, it's also gotten from ore, and this is used in the production of cable wires, pipes, and alloys. So from ore, you can also get copper. Okay, that's the copper pyrite, and is used for the production of cable wires, pipes, and alloys. Okay, so quickly, in the next 5 minutes, I have 5 minutes left. Let's look at the natural gas. So I'm done with the oil now, the mineral oil. Next one is natural gas. Quickly, natural gas is used for the production of domestic fuel and sulfur. Okay, natural gas for the production of domestic fuel and sulfur. That's the one used in cooking, the gas used in cooking. And then for the crude oil, so I'm done with natural gas. The crude oil is not just a raw material, as we all know. Okay, it's not just a raw material for petroleum industries. Because when you say crude oil, the first thing that comes to our mind is petroleum industry. Okay, it's also a raw material for chemical industry. So crude oil is also used, apart from the petroleum industry, is also used in chemical industries. Okay, now this crude oil, when subjected to fractional distillation, because that's how you separate, bring out different products from the crude oil. So to get these different products, you have to subject the crude oil to fractional distillation. Now, once it's subjected to this fractional distillation, you get a lot of products from this crude oil. Example, the premium motor spirit, PMS, which of course is fuel. The use of PMS is fuel for our cars, our vehicles. You get DPK and HHK, dual purpose kerosene and household kerosene, okay, which is used for cooking and for aircraft. Aircraft also use DPK. Then you also get diesel, which is the automated gas oil. Heavy duty machines basically depends on this. You get your liquefied petroleum gas and the liquefied natural gas, which is used in labs. Okay. Now, other petroleum products from that crude oil includes lubricating oil, bitumen, naphtha, petrochemicals like the ethane, the benzene, and the phenol. And these ones are used in petrochemical industries for production of fertilizer, drugs, synthetic rubbers, paints, and dyes. Let me take it again. I said the crude oil, after fractional distillation, you get PMS for vehicles, DPK for kerosene for cooking and for aircraft, diesel for heavy duty vehicles, LPG and LNG for labs. Then other petroleum products include lubricating oil, bitumen, naphtha, petrochemicals. All these are used by petrochemical industries for the production of fertilizers, drugs, synthetic rubbers, paints, and dyes. And then finally, the sulfur, before we round up today's class, the sulfur, that's a hydrogen sulfate now, H2SO4. The hydrogen tetrasulfate 6 is gotten from this sulfur. And this H2SO4, the hydrogen tetrasulfate 6, is used in the production of car batteries, okay, explosives, dyes, paints, fertilizers, and synthetic fibers. I take it again. So I said sulfur, which is hydrogen tetrasulfate 6, is gotten from sulfur. H2SO4 is gotten from sulfur, and they are used in the production of car batteries. They are also used in production of explosives, and they're also used in the production of dyes, paints, and fertilizers. Also, synthetic fibers are also produced from sulfur. So that is that for the uses of industrial raw material as far as the earth and water is concerned. So hopefully in the next class, we look at the raw materials obtained from the air. You know, I told you there are four sources of industrial raw materials: the earth, the water, the air, and agricultural products. So we're done with the earth and the water. So in the next class, we'll continue from the air, the raw materials gotten from the air, and of course, the uses. Thank you very much for today's class. I will see you guys next week. Thank you.